Hello and welcome to Maths with El Profe Lo, looking at some word problems from this Unit 2B. Okay, we have a problem here that tells us about a rectangular area adjacent to a river and it's to be fenced in. No fence is needed on the riverside. The enclosed area is to be 1,000 square feet. Fencing for the side parallel to the river is $5 per linear foot. Right, I could make sure I capitalize that. And fencing for the other two sides is $8 per linear foot. The four corner posts are $25 each. Let X be the length of one of the sides perpendicular to the river. So I need to sketch and label a diagram with this information. All right. So let's say that I have a river, right? And I am going to have, some fenced in area, right? So here's my fenced in area, and I know that that fenced in area needs to be 1,000 feet squared, right? I know that I'm going to have four corner posts, right? So I can set up my corner posts, and I am told that X is the length of one of the sides perpendicular to the river, right? And we're told that this is rectangular, so we'll call this side X, we'll call that side X, and we might call that W for the width. Okay, so there's our initial information, right? It is useful to say that the area, which we know is going to be 1,000, right, is going to be, right, that length X times W, right, which then also tells me that W must be equal to 1,000 over X. That information might be useful to me later on. Okay. So after sketching and labeling our diagram, we're asked to write a function c of x representing the cost of the project as a function of side x with the domain clearly indicated, right? So a lot of times for these problems we might do a little bit of work and then have to come back to finish up our work, right? Now certainly it would make sense that x is not going to be negative, right? And so we might start off with this side length is going to at least have to be positive. So we'll keep that in mind, right? We'll keep in mind that X, right, is going to have to be greater than 0. And we might have some other bound to what we have, right? We might also say, hey, I know that X is going to have to be less than maybe 1,000 because we know that the area is 1,000, right? So we might have some particular limitation there, right? But we'll work with our calculator and check this information out a little bit more. So we want c of x to represent the cost, right? And so I'll scroll down here so we can see a little bit more clearly, right? And we'll say, so the cost, right, is going to be given by, and let's just go ahead and talk about, right, the cost. The cost, we know we're going to have four posts at $25 per post, right? And we also know that we're going to have the fencing parallel to the river is $5 per linear foot, right? So we're going to have, let's see, $5 times however long W is. And the other two sides is $8 per linear foot, right? And these are two sides of length x, so I'm going to have $8 times 2x, right? So that's going to be the parts that make up my cost, right? So if I come over here and I say, okay, well, what's that going to give me? That's going to tell me that the cost is a function of x, right? 4 times 25 is $100. Right, so I'm going to have $100 plus 8 times 2, that's 16x, plus 5 times W, right? And W is equal to 1,000 over x, so this is going to be then plus 5,000 over x. And so now I have my cost equation as a function of x, okay? Now, in terms of the domain, right, we'll know that x isn't going to be 0. We know x needs to be positive, right? And so we might come over here and check to a few of our other features. And so we'll say, well, let's, sketch the graph and see what information we can get. So we're going to come over here, all right, turn on our calculator. We have a graph from a previous piece of work. We'll come over to the y equals and put in our new graph. 100 plus 16x, all right, plus 5,000 divided by x, right? Now, I always recommend to write the functions, if your calculator has the feature, using the fraction format. All right, and that's citing alpha y equals, and that gives me 5,000, right, all over x. Okay, so if I hit zoom, right, and I look to my particular function, right, I say, hey, I want to fit my function, I can go down to zoom fit, all right, select that zoom fit, and it should, right, give me kind of close information for my function, right, and I can now see my cost equation kind of on what's going to happen. I can look to see that I do have a little bit of minimum, right, so I'm going to adjust my window, and I know that my x minimum, right, of -1 should be fine. My x maximum of 100 look to be okay, right? But this y minimum, I'm not going to have a negative cost, right? So I might change that y minimum to be -1, right? And then that y maximum, right? Well, we'll go ahead and see what it looks like with just these adjustments, right? And even with just those adjustments, we can see a little bit better the shape of our graph, right? And if I do change this y maximum, let's say we go to 5,000 with the y scale of 100, right? So now I have my graph a little bit better, right? So I can see that there is a minimum cost, right, after which the cost does start to increase again. So I'm going to go ahead and sketch the graph of this function, all right? So once again, I am only working in the positive realm, right, and my function seems to do something like that, right, and I do seem to have some minimum value. I do seem to have some minimum value where I have the least on my dimensions, a minimum, and we can calculate that by saying second, calculate my minimum, right, and I can arrow to the left of my minimum. All right, so come over, arrow over, there I am to the left. I can arrow over, there I am to the right. Press enter, right, and guess, and it gives me this minimum, right, that the x value is about 17.7 and the y value is about 665.7, right? So what does this tell me, right? This tells me that the least expensive enclosure, right, the least expensive enclosure is going to cost $665.70 approximately, right? And that will be when x is equal to 17.7 feet, right? Now, if x is equal to 17.7 feet and w is equal to 1,000 divided by x, then w is going to equal, well, let's check that out, 1,000 divided by 17.7, and that gives us about 56.5. Right, so if we took that 56.5 and multiplied it by 17.7, we should see that we get right close to that 1,000 square feet that we're looking for. Okay, so let's check to make sure that we've answered everything, right? Did we sketch a graph of the cost function and determine the dimensions of the least expensive enclosure, right? Well, this was our cost function, and our dimensions, we want to be clear in our response. Our dimensions are 17.7 feet by 56.5 feet, right, where this is perpendicular and that is parallel, right? And this is to the river, because that's what we're told. Okay, so if we come over here, what we say, all right, cost of the project of function inside X with domain clearly indicated, right? We might be able to then come over here and say that, hey, yes, certainly the domain, right, is going to be that X is between 0 and 1,000. And the reason being, right, if we had this width be 1 foot wide, it wouldn't make much sense, right? But it still would fit within our constructs. And of course, X needs to be positive. So X needs to be, at least more than 1 foot. Okay, so there we go. We have a problem, right? Quite a few steps, but we need to make sure that we can go through and label each of the given pieces, right, and to be able to answer the questions associated. So this has been Maths with El Profelo. As always, ask questions for clarification. I thank you for your time.